Welcome back to the deep dive, everyone. I am so excited about today's topic because we are going to be drawing with some very thick lines today.
We really are. It's a topic that requires a broad brush.
Yeah, exactly. We want to keep the vibe bright, clear, and really accessible because, usually when you talk about high-level physics, things get bogged down in like super dense equations.
Right. The math can get overwhelming very quickly.
But today's mission for you, the listener, is to paint a really bold picture of a fascinating and honestly kind of rebellious critique. We're looking at a blog draft called Draft. Mr. Einstein slacking 147 organizing from Senior Romer.
Which is quite a title.
Oh, it really is. And the
Yeah.
core argument is just as punchy. The author is essentially claiming that Albert Einstein, like the Einstein, made a massive spatial recognition error in his theory of relativity.
Yeah, and what's fascinating is that the author isn't saying Einstein, forgot to carry a 1 in a calculus equation. They're arguing something much more fundamental. They're saying Einstein forgot to include the most crucial element in any physical space, the observer.
Okay, let's unpack this because, we're talking about the guy who basically mapped the modern universe for us. How does someone like that allegedly make a mistake about just looking at things?
Well, the blog breaks it down into two different ways of seeing the world. You have a mathematician's eye and the camera eye.
Okay, mathematician's eye versus camera eye.
Exactly. When Einstein was coming up with his thought experiments, he was mostly using the mathematician's eye. Think of it like a God's eye view.
Like looking down at a perfect map of the city.
Yes. You see a perfect 3D geometric grid, an X, Y, and Z axis. And in that mental space, you instantly know where every single object is.
You just magically see the whole board at once.
Right. It's simultaneous knowledge. But the author draws a really thick line here and says, that's not how reality works. Because we don't live on a piece of graph paper.
No, we live in a physical universe.
Yeah. We live in an electromagnetic field. And in that field, information is not instantaneous. Light has a strict speed limit.
So you literally can't have a God's eye view.
You can't. You have to use the camera eye. You have to account for the physical position of the camera, the observer, and the actual time it takes for the light to travel across space to hit that lens.
Oh, wow. So he's saying Einstein forgot the travel time of the light itself.
He forgot the delay. And the text brings up some great historical context to ground this. They mention Senior Galileo and Senior Romer.
Right, because Galileo was actually out there looking at stuff, not just doing math in a dark room.
Exactly. Galileo would stand on a beach with a telescope watching a physical ship sail away. He defined a real physical relationship between his organic eye and the object.
He was a localized camera.
He was. And then later, astronomers like Ole Romer and James Bradley realized that because light takes time to travel, the Earth's movement actually changes the apparent direction of the stars.
That's the stellar aberration thing, right?
Yes, stellar aberration. It's like, well, think of running in a rainstorm.
Okay, I'm picturing it.
If you stand still, the rain falls straight down. But if you start sprinting forward, you have to tilt your umbrella forward.
Right, because you're running into the drops, so they feel like they're coming at you from an angle.
Exactly. The starlight is the rain. Because the Earth is moving and the light takes time to reach us, the stars appear slightly shifted from where they actually are.
That is such a bright, clear analogy. It's honestly like, it's like watching a live stream of a sports game, but you completely forget your internet has a 10-second lag.
That's a perfect way to put it.
You're cheering, assuming you're seeing the game exactly as it happens, but you're cheering for the past. But wait, I have to push back here.
Go for it.
Didn't Einstein literally build his entire theory of relativity on the speed of light? Like, the speed of light being constant is his whole thing. How could he forget the lag?
It's a great question. The author isn't saying Einstein forgot the speed of light exists. They're arguing he misapplied it.
Misapplied it how?
He used the math of the speed of light, but he didn't put himself as a physical camera inside the space to receive it. He treated a light beam like a solid line drawn on his mental map.
Rather than a physical signal making its way across a room.
Precisely. And this leads perfectly into how the author completely deconstructs Einstein's most famous thought experiment.
Oh, the light clock. Okay, let's paint a really vivid picture for everyone listening.
Let's do it.
So imagine a completely transparent train. It's moving incredibly fast along a straight track, let's say 10% the speed of light.
Okay, very fast train.
And inside this train car, there's a clock. But instead of a ticking pendulum, it uses a pulse of light. The light shoots up from the floor, hits a mirror on the ceiling, and bounces back down. Tick-tock.
Right. So for someone sitting on the train, the light just goes straight up and straight down.
Exactly. But Einstein said, okay, what about a guy standing on the platform outside watching the train zoom past?
And this is where the textbook time dilation comes from. Einstein reasons that to the guy outside, the train is moving forward while the light is moving up.
So the light can't just go straight up. To hit that ceiling mirror, which is now moving away, the light has to travel in a long, slanted diagonal line.
Yes. And because that diagonal line is physically longer than a straight vertical line, and light can't speed up,
It takes longer for the light to bounce, meaning time is literally moving slower for the people on the train. It's such an elegant idea.
it is. But here is the author's bold rebuttal. The author claims Einstein conceptually enslaved the light to the train.
Enslaved it, like he assumed the train was dragging the light along with it.
Exactly. The critique is that once that photon of light leaves the atoms of the floor, it enters the universal electromagnetic field.
Oh, wow. So it's not part of the train anymore.
No, it's entirely independent. It doesn't care about the train's forward momentum.
Okay, but how does that break the math? Walk me through it.
Let's use easy numbers. Let's say the train ceiling is exactly 10 units high. And in our 10-second window, the train moves forward exactly 1 unit on the x-axis.
Okay, got it. So the ceiling mirror has moved 1 unit to the right.
Right. Now, to follow Einstein's diagonal path, the light has to travel across a right triangle 1 unit horizontally, 10 units vertically.
Which means calculating the hypotenuse.
Yes. And the square root of 101 is roughly 10.05.
Okay, so the diagonal is 10.05 units long.
But here's the mathematical trap. Light has a strict speed limit. If it only has 10 seconds to travel, it can only cover exactly 10 units of distance.
Oh, I see it. It physically cannot stretch to cover 10.05 units.
Exactly. It doesn't have enough gas in the tank, so to speak.
Right.
By the time the light travels its 10 units, the moving ceiling mirror is already gone.
The light completely misses the target. Wow.
That's the argument. Einstein drew a perfect diagonal on his mental map, but physical light with a finite speed wouldn't make the jump.
Because he used his God's eye view and ignored the camera's reality. Here's where it gets really interesting, though. If the map is broken, how do we fix it?
Well, the blog suggests we have to reverse engineer reality from the ground up using multiple local cameras.
I love how the author does this. They use these 3 vibrant characters named after historical Chinese commanders. It gives the physics this really cool tactical feel.
It's a great framing device.
So we have camera 1, Han Xin. He's the field commander right in the mud, stationed at the origin point 000.
All right, he's right next to the event. Then you have camera 2, Xiao He. He's the strategist watching from a distance, say 0, -10, 1.
And finally, camera 3, Liu Bang, the king. He's way up high in a watchtower at coordinates 0, 0, 20.
Now imagine an event happens, a star goes supernova. The light from that explosion hits Hanxin, Xiaohe, and Liu Bang at entirely different times.
Just because they're sitting at different distances.
Yes, but it's not just distance. The author brings in this idea of a headwind or a tailwind in the electromagnetic field.
Wait, a headwind for light. How does that work?
It just means if one of the commanders is physically moving toward the supernova, they're running into the light, so the signal hits them faster.
Oh, like the umbrella in the rain analogy again.
Exactly. And if they're moving away, the light has to chase them down, which takes longer.
So Han Xin logs the explosion at, say, 2 p.m. Xiao. He says he saw it at 2:05, and the king sees it at 2:15. That just sounds like total chaos.
It would be chaos if they only trusted their raw visual data. But Liu Bang, being the king, knows how to read what the author calls the historical time map.
Ah, so he doesn't just take the raw video feed at face value.
Right. He collects the delayed reports, factors in everyone's distance and movement, and mathematically strips away the delay.
He normalizes it all.
Yes, he creates a true global public space map. Kind of like Greenwich Mean Time.
That makes so much sense. So physics isn't just about what happens out in the void. It's entirely dependent on when the news of that event reaches you.
Precisely.
Which, honestly, completely changes how we look at the night sky. Like, think about this. If you walk outside tonight and look up at Betelgeuse, you feel like you're experiencing it right now.
But you aren't.
No. That star is hundreds of light years away. You are literally staring centuries into the past. Spatial distance and temporal distance are just mashed together.
And if we connect this to the bigger picture, the author makes a really profound comparison to quantum mechanics.
Really? How does an exploding star connect to tiny quantum particles?
They bring up Heisenberg's uncertainty principle, and specifically, a correction made to it in 2003 by Professor Masanao Ozawa.
Okay, remind me. Heisenberg is the idea that you can't measure a particle perfectly, really.
Basically. He thought that the act of measuring a particle inherently blurs its position or momentum, but Ozawa mathematically proved that Heisenberg had confused two things.
Was it confusing?
He confused the natural inherent fluctuation of the quantum particle itself with the physical error caused by the scientist's measuring instrument.
Oh. So he blamed the universe for his clumsy camera.
Exactly, and Ozawa's inequality successfully separated the two.
And the blog is saying Einstein did the exact same thing, just on a galactic scale.
That is the core of the whole argument. The author believes Einstein confused perfect geometric space with the messy, delayed reality of actually capturing light images.
He confused the map with the street corner.
He absolutely did.
Wow. So what does this all mean for us? Like, if this dense, rebellious draft is right, what's the ultimate takeaway for the listener?
Well, whether or not the blog's specific math entirely overthrows a century of relativity, that's almost beside the point.
Right, it's bigger than that.
The real value is the reminder that we always have to question the framework of our observations. We are never completely outside the universe looking in.
We can't separate the observer from the observed.
Exactly. Our eyes, our telescopes, they are physical objects inside the universe, subject to its speed limits and delays.
We're just organic cameras capturing delayed light, which is such a wild thing to realize. Next time you look up at the stars, or honestly, even just across a really big room, you're looking into the past.
You really are. And I'll leave you with a final, somewhat provocative thought.
We love these. Hit me.
If every piece of visual information we ever receive is just a delayed broadcast from the past, does a universal present moment actually exist anywhere outside of our own minds?
Oh, wow.
Or are we all just individually writing the lag of the universe?
Are we all just living on a delay, trying to piece together a reality that's already moved on without us? That is incredible.
Ugh.
I've got chills. Thank you so much for breaking this down with me today.
It was my pleasure.
And for everyone listening, keep questioning the maps you're handed and keep looking closely at the world around you. We'll catch you on the next deep dive.